Welcome to the fourth class on this physics concept, uniformly accelerated motion. In today's class, we are going to proceed by solving series of past exam questions on this topic, uniformly accelerated motion. Okay. For adventure, if you missed the first, second, and third class, you can check the link in the description of this video to watch those classes. Okay, let's have the first question. A body uniformly accelerates from rest at 8 meters per second squared. In how much time will the body travel a distance of 2.5 kilometers? Okay, let's start by writing out the parameters that were given in the question. We are told that the body accelerates at 8 meters per second squared. That is, the acceleration is equals to 8 meters per second squared. Okay, now please pay attention to that statement. The body accelerates from rest, and in our previous class we've learned that if a body starts from rest, the initial velocity of that body is what? 0. Okay, so therefore u is equals to 0. Do you understand? Okay, now the question says, in how much time will the body travels a distance of 2.5 kilometers? Now, that is what we are asked to calculate. What we are asked to calculate is the time. You understand? And we are given that the time that the body will take to cover the distance of 2.5 kilometer. Okay? Now, don't forget, in our previous class, I told you, if you are not told to leave your answers in any unit, it is very, very important that you convert all the parameters that are given to the SI unit. I pay attention. For example, look, we are given the distance in kilometer. You understand? We are given the distance in kilometer. So the first step now is that I'm going to convert this distance to meter. Okay? So if you want to convert 2.5 kilometer to meter, all you have to do is that you have to multiply it by 1000. You understand? Because 1000 meter is equals to 1 kilometer. So for this, I'm going to have this can be written as 2.5 multiplied by 1000. You can do this without calculator because 1000 has 3 zeros. So I'm going to move this decimal point 3 times. That will be what? 2500 meter. Do you understand? Okay, having convert the distance from kilometer to meter. Now look at the parameters that we are given. We are given A, we are given U, we are told to calculate the value of T, and we are given S. The most appropriate equation to use is this. Do you understand? Because I've been given the distance, that is S is equals to UT plus half AT squared. Now, S is what? 2500. So I'm going to have 2500 is equals to U. U is 0. So I'm going to have 0 multiplied by time. Time, I didn't know the time. You understand? The time is what I'm told to calculate from the question. So 0 multiplied by time plus 1 over 2. Acceleration is 8. Multiplied by 8 multiplied by t squared. Do you understand? So I'm going to have 2500 is equals to 0 times time is what? 0. You understand? So for this, I'm going to have 1 over 2, 8 multiplied by t squared. Do you understand? You see? The parameters that you are given in the question will tell you the appropriate equation to use. Do you understand? I cannot make use of this first equation. The reason is because I wasn't given the velocity. You understand? I am not given the velocity of the object. I'm only given the initial velocity. And from the first equation, the final velocity is equals to the initial velocity plus the product of acceleration and time. You understand? But I cannot make use of this equation because I didn't know the final velocity. You understand? So the parameters that I'm given tells me which of this equation am I going to use. So I see the equation of motion that is suited with respect to this parameter is the second one. So I make use of the second one to calculate the time. Okay? So pay attention. Now let's proceed. For this, I'm going to have 2500 is equals to 8t squared all over 2. Do you understand how I got this? 8 multiplied by t squared, that is what? 8t squared. Then 1 over 2 multiplied by 8t squared, that is what? 8t squared over 2. Okay, so this 2 here, 4. So I'm going to have 2500 is equals to 4t squared. What do? You divide both sides by the coefficient of t squared, which is 4. So I'm going to have this over 4 and this over 4. Now 2500 divided by 4, that is 625. Okay, so for this I'm going to have 625 is equals to t squared. Please, do you understand how I got this? Now I'm not looking for t squared, I'm only looking for time. Okay, so what do? You take the square root of both sides. So for this I'm going to have square root of this and square root of this. The meaning of square root is this. When you take the square root of t, look at this. We have what? Oh, let me change this marker, okay? Now we have t squared. Look, t squared is equals to 625. Now when you take the square root, with square root of this, with square root of this, the meaning of square root is t squared multiplied by 1 over 2. Do you understand? So, and 625. The square root of 625 is 25. So I'm going to have is equals to 25. By the time we take this, we are going to have this we multiply, these two we cancel, we divide these two. So I'm going to have t is equals to 25 seconds, because the square root of 625 is what? 25 seconds, because the unit of time is what? Seconds. Okay, so that's how to solve the question. Let's have another work example. A particle starts from rest and moves with a uniform acceleration of 4 meters per second squared. What is its velocity after covering a distance of 8 meters? Okay, I want to do something now. I want you to pause this video, then attempt the question. Then when you are done, play the video to check the solution to the question. Okay, now let's start. We are given that the particle starts from rest. You know, in our previous class, I gave you three conditions. If a body starts from rest, the initial velocity of that body is 0. You understand? Because velocity refers to the distance moved in by an object in a specified direction. Okay, so u in this case is what? 0. Please, I don't want you to forget this. Okay, u is 0 when an object starts from rest. So u here, sorry, let me change this marker again. Okay, so u is 0. Do you understand? Okay, now the particle accelerates from rest and moves with a uniform acceleration of 4 meters per second squared. That means a is equals to what? 4 meters per second squared. What is its velocity after covering a distance of 8 meters? Now we are told to calculate v. We don't know the value of v, and we are given that s, which is the distance, is equals to what? 8 meters. Now, looking at these parameters that were given in the question, which of the equation of motion are we going to use? Are we going to use the first? How are we going to use the second? How are we going to use the third? Okay, let's look. Let me just tell you something. Look, if you want to use this, v is equals to u plus 80. I'm not giving the time. You understand? I'm not giving the time, so I cannot use the first one. Okay? You know, I'm looking for v. V is present, but I'm not giving the time in the question. Okay? And if I want to use this, s is equals to ut plus 1 over 2 at squared. I'm not giving the time again. So the most appropriate equation of motion to use in this case is the third one, which is v squared is equals to u squared plus 2as. Anytime you are dealing with this concept, first write out the parameters that you are given in the question. Okay? So the parameters will tell you which of this formula are we going to use. So I'm going to use the third one. V squared is equals to u squared plus 2as. Okay, I'm looking for v, so there is no need for anything. U is what? 0. 0 squared plus 2 multiplied by a. A is 4, so I'm going to have multiply by 4 multiplied by s. S is 8, so multiply by 8. Do you understand? Okay, now we have gotten to this point. 2 multiplied by 4, v is equals to 2 multiplied by 4, that is 8. 8 multiplied by 8, that is 64. So I'm going to have, let me just put it, 8 multiplied by 8. V squared is equals to 64. So v is equals to the square root of 64, which is what? 8. So the velocity is 8 meter per second. If you get this, you get the correct answer. Okay, so let's have another work example. A motorist traveling at 120 km per hour sees a broken down truck at the middle of the road and immediately applies his brakes and comes to a stop with uniform retardation in 20 seconds. What distance does the car travel after the brake were applied? Okay, you know, in our previous class, that should be second or third class, we learned the concept of retardation. Retardation simply means negative acceleration. It is the kind of acceleration that brings the motion of an object to rest. Okay, so let's start by writing out the parameters that were given in the question. Okay, the motorist was traveling at 120 km per hour. You can see now, 120 km per hour, is that acceleration or speed? That is speed. And this kind of speed is velocity because it has direction. Okay, so the velocity is 120 km per hour. Now, if we talk about velocity, velocity in uniformly accelerated motion can either be final or initial. Okay, is this initial velocity or final velocity? I want to guess. Yeah, this is initial velocity. Okay, please, you know, I gave you 3 conditions in the second class. I told you, if a body is starting from rest, the initial velocity of that body is 0. Now, if the body comes to rest, that is, the body is on the motion before, is moving with a particular velocity before, that velocity is what we call the initial velocity. And the body comes to rest. When such body comes to rest, the final velocity of that body is 0. And the initial velocity will have a significant value. Okay, so example of such condition is this. You know, the motorist was traveling at 120 km per hour before. So therefore, the initial velocity u is what? 120 km per hour. U is equals to 120 km per hour. Please, I want you to pay attention because this is a multi-step problem. Do you understand? Okay. Now, we are told that the body comes to stop with uniform retardation in 20 seconds. So the time that was given in this question is equals to 20 seconds. Please, do you understand? The first step is that I'm just writing out the parameters that I was given in the question. Now, we are asked to calculate the distance that the car traveled after the brakes was applied. The distance S is equals to unknown. We don't know the values of the distance. Now we have to calculate the distance. Now, what's the first step? The first step is here, change this to the SI unit, which is meter per second. The unit of velocity is meter per second. So change this initial velocity to meter per second. We have 120 km per hour. This 120 km per hour. 120 km. Please, this is 120. 120 km per hour simply means 120 km per hour simply means 120 km all over 1 hour. Do you understand? That is the velocity which the motorist was moving at the initial velocity of 120 km per hour. It covers this distance in an hour. Do you understand? Now, if you want to change 120 km per hour, you want to change it to meter per second. Let's start with the distance first. Let's start with the displacement or distance, you can call it. But you know, when direction is added to distance, we call it what? Displacement. Okay, so look, 120 km all over 1 hour. If you want to convert this 120 km to meter, what do? You multiply it by what? 1000. So I'm going to have 120 multiplied by 1000 all over. Now 1 hour. We want to convert 1 hour to seconds. Don't forget that 60 minutes, 60 seconds is equals to 1 minute. You understand? And 60 minutes is equals to what? Is equals to 1 hour. So how many seconds will be equals to 1 hour? That will be what? 60 times 60. Do you understand? So I'm going to have all over 60 multiplied by 60. This will be what? 120,000. 120,000 all over 3,600. Okay? So this zero will cancel this zero. So we are left with what? 1,200 divided by 36. 1,200 divided by 36, that is 33.33. Okay, this will give us 33.33. So let me erase this. Okay, so this is equals to 33.33. Oh, 33. This is equals to 33.33 meter per second. Okay, so you've seen that that's how to convert this to meter per second. Now, how do we determine the distance? To determine the distance, we first need to determine the acceleration. Okay, please, I want you to pay attention. To determine the distance, we first need to determine the acceleration, which is also known as the retardation. Okay, because the question says determine the distance that the car traveled after the brakes was applied. The brake that is applied to the car is what makes the car stop. You understand? And that's what makes it undergoes retardation. You understand? So the kind of acceleration that we want to calculate here is retardation. Do you understand? So don't be surprised if you have a negative A. Do you understand? Okay, let's go. Now, to calculate the retardation, which of these equations are we going to use? Are we going to use the first, second, or third? We are given the initial velocity, we are given the time, we are told to calculate the distance. Also, because the car comes to rest, immediately the brake is applied, it comes to a stop with a uniform retardation in 20 seconds. That's what we are told in the question. So, because in the question, the car comes to rest, therefore, V, which is the final velocity, is equal to 0. Do you understand? Now, we are told to determine the distance, but we cannot calculate distance without knowing the acceleration, as I've already told you earlier. So, we first have to determine the acceleration. Acceleration is equal to what? Change in velocity over time. Okay? Acceleration, we can even use this. Let's use this. Okay? V is equal to U plus AT. You understand? We want to make A the subject of the relation. Okay, so the first step is that I'm going to have AT, take U to the other side of this equation. I'm going to have V minus U is equals to AT. Do you understand? Divide both sides by T. I'm going to have this over T and this over T. So this T will cancel this T. So I'm going to have A is equals to V minus U over T. Do you understand? Now, acceleration here will now be A is equals to V. V is what? 0. So I'm going to have 0 minus U. U is what? 33.33. Okay? So 0 minus 33.33 minus 33.33 all over T. T is what? T is 20 seconds. Do you understand? So I'm going to have all over 20 seconds. So now, if you divide for this, I'm going to have A is equals to 33.33, okay, negative 33.33 all over 20. No, this is not 205, it's 20 seconds. So okay, let me remove the seconds now. You understand? So you won't get confused. Okay, A is equals to negative 33.33 divided by 20. That will give us A is equals to minus 1.67 meter per second squared. You can see this kind of acceleration is retardation. Okay, retardation is negative acceleration. Actually, you can see that it has a negative sign. Okay, so the acceleration is negative 6 points. A is equals to minus 1.67 meter per second squared. Do you understand? Now, we can easily determine the distance. Okay, because we've known the acceleration, we can easily determine the distance. If you want to calculate the distance now, which of these equations are we going to use? The best equation to use is the second equation, and you can also make use of the third equation. Okay, because the distance is present in both of these equations. So if you make use of either the second or the third equation, you're going to get the same answer. Okay, let's use the third equation. For this, I'm going to have V squared is equals to U squared plus 2AS. V is 0, so I'm going to have 0 squared is equals to U squared. U is 33.3, so I'm going to have 33.33 squared. Okay, is equals to 2 multiply plus 2 multiplied by A. 2 multiplied by negative 1.67 multiplied by S. Multiplied by S. Okay, now 0 square is 0. You understand? and 33.33 squared is 1110.89. So I'm going to have 0 is equals to 1110.89 plus 2 multiplied by negative 1.67. That will give us minus 3.34. So I'm going to have plus minus 3.34 multiplied by s. Okay. Now I'm going to take this to the other side of this equation. You understand? So I'm going to have minus 1110.89 is equals to positive times negative. That is negative. So I'm going to have negative 3.34s. Okay, this is not 5, it is s. Okay, now the next step is that I'm going to divide both sides by what? Negative 3.34. So I'm going to have this over negative 3.34 and this over negative 3.34. Do you understand? So s will be equal to 1110 divided by 1110.89 divided by negative 3.34. That is 332.60 meter. 332.60. The unit of distance is meter. So the distance that it covers after the brake is applied is 332.60 meter. You can see that the question is simple. So that's how to solve question on uniformly accelerated motion. If you have any question, you can reach me on WhatsApp. Okay, see you in the next class.
To watch the next class, kindly check the description of this video. You are going to see a link there. Click on that link, or you should check the playlist on this channel. Okay, see you in the next class.